This is my current foundation class transceiver project. On this video I'm going to go through the AGC setup on the receiver. Here we have a block diagram of the AGC system of the receiver. The RF preamp, the IF amplifier, IF AGC detector, AF AGC detector, and a small buffer amplifier going to the TFT meter. Over here we have the AGC bus board, which combines the two AGC signals. They go through the board, through a switch, onto the IF and RF gain controls and control these two stages. We can switch to manual, where we inject a fixed voltage into these two amplifiers, so the gain is just not controlled automatically but just fixed by the adjustments of these two controls. Down here we have a little chart which I made up during the prototype testing. The results of the tests are quite handy to keep online. If anything goes wrong, you can go back to these measurements and see if you're still getting those values. There are a number of trim pots that need to be adjusted in the AGC system, so I've made myself a number of steps that I'm going to go through and show on the video. So in step one, we're going to set the manual voltages to these two stages. We're just going to switch to manual, no signal coming in, so we just have a dummy load. We're going to adjust this trim pot VT4 for around 2.3 volts, between 2.1 and 2.3 volts on that line there. We have a little test point here that we can connect the meter up to. In this step we adjust trim pot VT4 for 2.3 volts going to the RF and IF preamps. You can hear the noise come up as I increase the voltage. It's quite high, and we go, that's too low, the noise is almost gone. We're really cutting the amplifiers off. 2.3 volts is where the receiver has effectively the maximum sensitivity. So that's the manual adjustment. It's done with a dummy load or no antenna. The RF and IF gain controls at maximum, and the AGC switch to manual. That's all there is to this first step. In the next step we have to set the bias on the IF AGC board under the same conditions, dummy load, etc., and it's still in manual. We're going to adjust this trim pot VT1 for 1.8 volts here. Why 1.8? The IF signal coming in has to overcome several junctions. The diode, about 300 millivolts, and then a couple of 0.6 volts for these transistors, and also the germanium, so there's 1.8 volts has to be overcome before anything will happen on the output. So by biasing this point to 1.8, we only really have to overcome the drop across D2, which is around about 200 to 300 millivolts. So we're on step 2, so we're just going to adjust this trim pot, VT1 it's called, for 1.8 volts on the cathode of that diode. So I'll just swing over to the meter. So we start adjusting it, and we're going to go for 1.8. I've turned the AGC to fast because the capacitors on the output of the diode will slow down the changing voltage. So chase our tail a little bit, so that's probably close enough. In step 3 we're going to adjust VT3 on the IF AGC board for 2.3 volts on test point 2. So that'll be VT3, this trim pot here, that's test point 2, just on the output. For test 3 I've actually got a convenient test point for that AGC output, the IF AGC, right up here on the bus circuit board. So I can adjust the trim pot by using that test point. So we'll adjust that trim pot. I've actually switched the AGC switch to automatic. There's no reason why you can't do that. What we're listening to is just the receiver noise without the antenna coming through. So as I adjust this control, as I turn it down, you'll hear the noise go down. That means the gain of the RF and IF amplifiers are very low now. And then we go back the other way, and you'll hear the noise come right up. This is receiver noise without the antenna. 2.3 is where you sort of get a bit of a threshold effect. It can be as low as 2 volts. Just depends on your amplifiers and the overall loop gain. So that's the adjustment, which was step 3. In step 4 we're just going to test the AGC the IF AGC system with the signal coming into the front end. So I've got a generator set up, and I'm going to monitor the AGC line voltage. So I've got an AM signal coming in on 7.150. I'm just going to bring the level up. You'll see it's 2.3 volts. As I increase the level using the RF tune, you'll see that voltage starts to drop. I've gone through it, so I'll go back and it goes down to about 1 volt. You'll see the S meter sitting around about S7 at the moment. So as we tune it in and out, you can see the AGC voltage going up and down following the signal strength. So it is working. So now at this stage we have the AGC reacting to a varying and AM signal. The BFO is off, so we can't hear the beat note, so we're just looking at the carrier. So now in step 5 we're going to check that the AM AGC board is working. We're going to feed tone. We're going to pick up tone from the generator by switching the transceiver to double sideband mode, and that tone is going to be rectified by the AGC diodes in the AF AGC module. As we adjust the trim pot, we should start to see a voltage appearing on the diodes in that module. So I've got the multimeter connected to those diodes, and I'm just going to start adjusting the input level. We want to see a change as we adjust the level of the audio getting to those diodes. So we've got tone coming through, and that's the voltage on the diodes, nothing at all. So as we adjust this trim pod, we're going to increase the signal into those diodes, and you can see it start to rise. There it goes. You really want it about, say about there maybe. You can adjust this later with a signal, audio signal, for the cleanest audio. If it's not enough, the peaks of the audio will distort. If it's too much, you'll be dropping the sensitivity of the receiver down too much, because it'll hold the AGC line down. So we've now adjusted VT1 so that we get a voltage here at the output of D1, which means that this amplifier is now feeding some audio signal into the diode. We got slow, which is a 100 microfarad capacitor, and fast, and there's a trim pot here, VT2, which you can adjust, which you'll see is across the this line. It goes across the 4.7 mic as well as the 100 if it's switched on, and it affects the delay time on fast. Now you want the attack to be relatively quick. It will be quick because it'll charge the capacitor up, but then the discharge of that capacitor will be via that. The input impedance is quite high. It's beta times the value of the emitter resistor, so most of the discharge will take place through this 100k trim pot. By adjusting that, you can set the discharge or the decay rate to maybe 1/4 of a second or whatever sounds good on fast. This amplifier will then feed the AGC line, and there's an adjustment here also which can be done later on to make sure that you're mixing the right amount of audio AGC with the IF AGC. That's best done by turning that one off and bringing only that one on, and vice versa. So I'm now adjusting that trim pot. You'll see it's sitting at around 1.3 whatever it is, with the signal generator going in at a certain signal stream. I've wound it back so that the audio AGC module is not affecting the AGC line. As I start to wind it up, you should start to see an effect on that line, and here it is starting to come down now. So now we know that the audio AGC system is adding to the overall AGC action. Yeah, I've advanced quite a bit now. There you go, that's quite a lot. And you'll hear the sound's dropped off because we're dropping the gain. And this is all being caused by me adjusting that trim pot, which is the audio AGC. There is a diode on this on the output of this module. That diode stops the AGC voltages on the IF AGC system getting back and affecting this circuitry here. So it only lets variations above the threshold of that diode on whatever voltage that's set to affect the AGC line. Once they get above that threshold of the diode, it starts to mix with this voltage here, and the AGC starts to vary the gain of the amplifiers. So you've got both audio and IF AGC acting together. Having adjusted all of these steps, we can now listen to some signals, and I'm also going to show you how to set up the S9 a little further down.
A place called Talbingo, which is right at the foothills of the Snowy Mountains, so we're about halfway between Sydney and Melbourne. But yeah, Greg is the one who inspired me to...
This is the RF tune control. You see it drop off.
Given homework the other day, Brett, that
I can switch the 20 dB
the
attenuator in. That's the attenuator in, the 20 dB pad.
Yeah, okay, well, I reckon Greg's probably...
now that signal's a little bit weaker because you can hear a bit of background noise come up, but the actual audio sounds pretty much the same.
It's quite enjoyable to check out what an individual is doing and what they're capable of.
So the AGC system is bringing the audio up to a similar level as the stronger signal. This is a double sideband. I'll go lower sideband.
Brett, absolutely. And I know nothing about
lower sideband mode.
Absolutely nothing. And I was inspired by Greg to have a go because I'd had a go before, and still a lot to do. But I've discovered in my very, very novice state there's this website called
In this demonstration I'm using a signal generator to produce an S9 signal. S9 on most transceivers is minus 73 dBm or 50 microvolts RMS. So I've got a signal generator and some attenuators, and I'm just going to show you the little setup I've got here. So first off, I'll show you the signal generator, and I've got it set for minus 2.9 dBm. I'm looking for minus 73. So if I set the signal generator at minus 2.9, which is close enough to minus 3 dBm, I know I've got to introduce an extra 70 dB. So after the generator, I've got a Hewlett-Packard attenuator. It's a very good quality one. It goes to 120 dB. I've got that set at minus 40 dB, and that attenuator is now feeding one of my homebrew attenuators, which are reasonably accurate. So that's down there on the bench, and we've got it set for minus 10 and minus 20, so that's 30 dB there, plus the 40 gives me the minus 70 dB. And that's going to the back of the connector on the radio. You can't see it very well from here, but it's just plugged into this connector at the back, down there somewhere. So we're feeding it with minus 73 dBm, which is an S9 signal. And there's the display on the FND1 minus S9. So we've adjusted the trim pots in the S meter circuit so that signal reads S9. So now I'll just switch in 20 dB to switch it out, I mean. So that's 20 dB removed, so we're now 50 dBm, minus 50 dBm. And that's 10 dB. I'll just turn it in and out. That's the 10 dB switch. So now we're at S9 plus 30. Above S9 the meter's quite good. Below S9 it's not so flash. It needs a little bit of work in the software. So that concludes a little demonstration on the S meter calibration. Above S9 it's a little bit compressed once you get past S9 plus 30, and below S9 it's very well spread out, so it needs a little bit of the software modifications. There's a closer look at the HP generator just down the side there, rather than the knob side. It's pretty good. Here's the chart I use for stuff. Download that off the web somewhere. So you can see I've marked S9 as minus 73 dBm. Not all equipment is necessarily calibrated for 50 microvolts RMS. Some equipment I believe is 100 microvolts RMS is also S9. Here's some examples of weak and somewhat stronger signals on 40 metres this afternoon. Fairly noisy band, propagation not that good.
Thank you very much for coming back to my phone, Rodney. Wish you a good activation. You are 3 and 3 in my side. All the best, 7 3s and 44.
You're good 5 and 9. Can we have your call sign again, please?
QSL, Victor, Q.
Roger. And Alf, I think the name is...
So this station in VK7 is only about a strength 1 or 2, and the other station from VK3 is about strength 6 or 7.
And it was Maki, the VK3 young FP was available. QSL.
Right, okay. What's your report, Henry? That report again, over?
Your report is 3 and 3, 33. QSL.
Roger, you're 5 and 9, Alfredo. Very nice signal there.
Right there, Bob. Did you say, excuse me, but did you say 44 degrees?
Yeah, Roger. 44 degrees here at the ranch, over.
That's 111 degrees Fahrenheit. Yikes. Well, does that qualify as, I know you guys have a phrase down there in your country, stinking hot. Does that officially qualify as being stinking hot? Over?
Yeah. Anything above 40, Brian. Anything above 40 degrees Celsius. Howling.
It's a little bit nicer on the double sideband filter.
And other ways for these bushfires to start, Brian, over.
Well, that's very hot, that's for sure. Well, you're right.
现代人的生活，它不再是压在箱底的嫁妆，而是可以走上国际 T 台的时尚符号。听了您的介绍，我们仿佛能触摸到那经纬之间流淌的温度与智慧啊！那您是如何看待正经在中华文化大家庭中的位置的？正经作为中国4大民警中唯一的少数民族支警，它不仅是正族文化的根与魂。
Here's an off-air signal. This is the Wireless Institute, Sunday morning. Coming into Victoria, Thaggy. A bit noisy, but it's okay.
CW, SSB and FT8. Team leader is XQ7IR and you can QSL via N0 URX, LOTW, Club Log OQRS.
This is lower sideband mode.
Radio,
And I'll go to double sideband mode.
Happy New Year to all. December is over and we are now almost through the
That's
second week of
double
January.
sideband mode.
Time is sure flying fast. Speaking of December,
Audio quality
happy
is
going to VK Yoda concert.
audio response is a bit wider,
I hope your log is
but there's a bit more
too. So let us
background
be
noise.
clear. Your everyday log can also be